Okay, so we're carrying on. I'm looking for where I'm supposed to be. Okay, here we go. So, in the interest of saving time, remember the session is being recorded. I'm going to demo the remaining portion. We don't have enough time for you to actually build it. And I'm sorry about that, but that's just how these things go. I know that I have to get ready for driving to Denver with the RV, and there are things I have to get done, and you've got planes to fly out and catch. So Azure DevOps. The first thing you do is you install Azure DevOps, or you activate it to your subscription. See if I can find it. So you have this document, not this document, sorry. Looks like I may have cleared that out. So let's do a new web search. So I did a web search on Activate Azure DevOps subscription. And I click down here to Azure DevOps pricing. And you can click here and it will take you right to logging in to your subscription. I'm going to go ahead and log in. Mine is already activated. And you see it says get started. I'm not going to actually click on continue because I'm already there. That has already been set up in my subscription. But that's how you would get there. Again, this is being recorded so you can find that. When that's finished, you'll end up with your shortcuts. You'll end up with Azure DevOps organizations. Now, in most organizations that are not greenfield, you will be told what your Azure DevOps organization is, and the person who's managing your project and your organization will assign you a role. However, clearly I can see with most of you that this is not the case. So you would create a new organization, and then you would go through the prompts. And in this case, which I'm not going to do here because our DevOps organization already exists, I would suggest that you web search Azure DevOps create organization, and then become very familiar with that document, read it a few times, and then create an Azure DevOps subscription within your trial subscription that is good for 30 days. After you create the organization, you'll create a project. I'm going to fictitiously walk through creating one. You can make it a public or a private project. I make almost all of my projects private. And this will create it. And the first thing you have to do is you have to go to your project settings, and you have to set up a service connection. And you can see that here we have AWS for Terraform. If I were doing Azure, I would select Azure Resource Manager. This should look familiar to you. The access key ID, the secret access. So now I would be going into AWS into IAM. That's not where I wanted to be. It's like that hotel bandwidth just got slow again. What else is new?
Is that service connector part of Azure?
Azure DevOps.
DevOps directly, or do you have to add it?
It's part of the project.
Okay.
And what I would recommend is that you have a different service connection for each project. Mm-hmm. Why? Because if something goes wrong and that basket gets dropped, that basket of eggs, or your Terraform state file gets screwed up for that project, you've at least, it's not the whole organization. It's just a subset.
But Azure DevOps should have an AWS connector built into it. You don't add it.
It's built into it, yeah. Yeah, if you were doing OCI or the IBM Cloud, then it would be a custom connector that you'd have to build. And that's not a trivial task. Okay, so now you would add a user as we did before. In this case, it's called Azure AZ DevOps. You would make that group, user a member of the admin users group that you created earlier, and you would go into security credos and you would create a key. Bearing in mind that the key has an expiration date here. Now, there is a way in Azure DevOps, if a security key expires, to update that in the service connection. And there are how-to documents with Microsoft to do this. When your service, your API key, first of all, two things about the API keys. You can either opt to make them as long as you can and then visit that devil when you have to, or you can make short lifetime keys that you rotate regularly, and you thus will be forced to learn how to do it and to get good at it all of the time. Right now, we're in our organization, we're somewhere in between, where every year the service connection expires and then we're forced for that client to go in and renew it. We are going to be moving in the direction of shorter keys as our maturity level increases with DevOps, and we'll be rotating those keys every 90 days so that we get really good at it. So you would create the key, you know how to get those values from here, and then you would apply them here, you would give the service connection a name, and you would grant that service connection access to all pipelines. And this is important to get right. Now, in the case of AWS, I suspect that you would, when this expires out, that you would delete and recreate the service connection and everything would still run. Why do I suspect that? Because the access key ID is not changing. And you cannot modify the access key value once you created the service connection. That's why you'd have to drop and recreate it. However, if you drop it and recreate it with the same name, your code is going to run without modification. That's the important thing. Keep the name the same. In the case of Azure, an Azure ARM service connection, it is married to the service principal. And when the service principal certificate expires, You have to renew that properly. Otherwise, if you inadvertently delete that service connection, you will never access your Terraform state again, and you'll have to re-import the entire Terraform state. Conversely, if you delete the service user in AWS and you recreate that service user, it's going to be a different set of credentials with a different ID number. You'll have the same net effect here, where your Terraform state is meaningless. You would have to import that entire Terraform state, and that is an arduous, highly error-prone, painful process. There was an open source group of people who were working on solving this with something called with an open source script that would import Terraform state. They ended the project because Terraform is changing so rapidly they couldn't keep up with it. And so, word to the wise: manage your keys correctly, manage your service connections correctly, or you're going to have a very long weekend and many nights ahead of you when the keys get farted up. So this is a completed project. And you can see under service connections, we've got AWS managed by Azure DevOps. And you see there's not much I can do. I can manage the service connection roles. There is no service principal for this. If I clicked on this, weird things would happen because this is an AWS service connection. And that's all I can do with it. Now in here I have pipelines. But actually I'm getting ahead of you on something and I need to fix that now. So hold on a second. So I'm doing a web search, Azure DevOps Marketplace. And that did not go well. Let's go to Google. There, remember I said before, sometimes it's better to go to Google to do a search than DuckDuckGo. There's a perfect example. This is marketplace.visualstudio.com/Azure DevOps. Before you can start terraforming in Azure DevOps, you've got to install the Terraform plugin to Azure DevOps. In order to do this, you just simply type in Terraform and hit enter. And now here's the officially sanctioned Terraform plugin. And this is the number of downloads in the past quarter, or actually in the past month. And here you see Charles Zip, and you can see the number of downloads in the past month are 22,900. And this is the search assistant here. And if we type up here, Terraform, and you see I highlight over here, I get the full description. And this is where I can type in the values. And I can go over here and select AWS. And the first thing I'm going to do is in init, validate, and then plan, and then stop right there, not doing anymore. That's one approach to take, where you'll actually test build the artifacts and then not go any further. And you can see right here, we've got the Amazon Web Connection here. We're not going to actually do this because this is already done. So if we look at the code for AWS, for the purpose of this demo, I've shortened it up, where the very top here, you've got Ubuntu latest for the microservice image type that will build the artifacts. And then we define our stages. And the first stage is named Terraform Validate Stage 1. And then we go to our tasks. And the first task is publish the artifacts. And this actually gets the repository that you define for this project, and it writes them. It pulls them down into the microservice. And the next thing we do here is we actually just simply call a bash function to list the objects. I'd like you to see this, though, where it gets created from scratch. So we're going to go through a mock operation to create a new pipeline. And here I'm going to click on GitHub. And it's going to prompt me to select a Microsoft credential. And now this will trick you up. It tricks me up every now and then when I'm tired. You want to go here because it's going to default to whatever your local repositories are for your personal GitHub account. And what's typically done is you create a GitHub account, and then your Git enterprise administrator in your institution asks you for that ID, and you say, here it is, and that person then grants you access to repositories. That's how it works in the real world. You go here and you'll select all repositories, and now you see all of your repositories here. You could do a keyword search here. Well, we're going to go ahead and access this. And now it's going to ask you, what do you want this to look like? And you want this to be a starter build. And now here, you're going to delete all that. And then you're going to go to the code. Here, the code that you downloaded. You see this here? AWS managed by AZ DevOps. See that? Just copy that whole thing. Oh, not that. And paste it in, just like that. And that's all there is to it on this part. I'm not going to save it. And what does it look like when it runs? There is the directory structure. You can see the Docker file, the README, See this file here? That's the actual name of the pipeline that we created here. So when I go back here, let's do it again, new project. Let's do the whole thing this time. All repositories. I'm going to pick that. We're going to do a starter pipeline. Look here, you see that? Azure pipelines.yaml. That's not a descriptive name. But that is a descriptive name. Okay, and let's run it. Now look here. It's going to commit directly to the master branch as the default action. Now, if I were creating a release branch and working off the release branch in the sandbox, I would click here and I would give it, the branch, a name, release, in our case, release underscore, what is today, the 21 OCT 2022.1 in this case. And then this file would get pushed to the repository. This should be turning the wheels in your head. I've cloned a repository down to my local developer desktop. You haven't actually created a private repo yet. So you would have to create a repository on your desktop. You would have to create a repository in GitHub, a private or public, usually private. And you can create one for free with the free account. When you do more than one, then you have to pay. And then you would push that repository up to GitHub. You'd have to do that before you would even see the repositories here. Now, when I commit this, and I'm not going to create a new branch in this case, I'm going to connect it directly to the master branch. It's doing two things. One, it is applying a git commit and a git push directly to github.com to my organization's repository that I just selected here. And now it's running the development pipeline. And what I'm looking for in particular is I want to see that the artifacts made it here. And they did. Now, if this were building an AKS cluster or a Kubernetes cluster inside of Azure, I would actually do the Terraform init, Terraform validate, Terraform plan here and stop. But because this is another cloud provider, I'm not doing that. At this point, I can create the release pipeline. But back to what I said earlier, if this were Azure, why would I do the Terraform init, Terraform plan, validate Terraform plan here? The reason why I would do it here is because it would fail. If it fails, and the pipeline will be marked as failed. And two, all of the output is nicely color-coded. So anything that failed is in bright red. It's easy to see. And number three, there's a history of that failure. When you do this in a release pipeline, you have to go through a bit more angst because you don't have the color coding. And what I have to do in that case is copy the whole thing down and literally print it to a printer and go through it line by line. That is the penalty we pay when we're using one cloud provider to manage another cloud provider. It's sexier and easier when it's running within their cloud. But when you go to manage somebody else's stuff, it's not quite as tight. We have to expect that. Now this is an artifact that's been created here. Now, one thing that may be of interest to you, you remember a while ago I said, before I do a git push, I'm always going to do a git pull. It just pulled a file. What file did it pull? And if I were to go to GitHub directly, you see, 4 minutes ago. Now I'm going to go here to the releases, and I'm going to create a new release. And I'm not going to do any of this yet. I'm going to click on X up here. You see I have no stage and no artifacts. I'm going to add an artifact and source. It wants to know what build pipeline created these artifacts. We already had AWS managed by Azure DevOps R3 from the previous setup. That's why I'm picking one here. And you see I could pick GitHub directly, but then I'm breaking the process. The point is, before I do a release pipeline, I want to have those artifacts built, and I want to know that they're as rock solid as possible and ready to go, and also that there is a history of them. If I go directly against GitHub, I'm going to be getting whatever is the latest in GitHub. And now I don't have any history, and that's not, in my opinion, the right practice. Now I need to click on this here. This is called the continuous trigger deployment. And I'm going to say, I'm going to enable this, which creates a release every time a new build is available, meaning anytime that development pipeline runs, this release pipeline will immediately trigger. And now, also, I can do this, and I can say, okay, if somebody goes in and changes something from the code's baseline, every night at 23:59 local time, I'm going to run that release pipeline off of the latest approved artifacts. Now, furthermore, after I push something into production, I typically go in here and turn that off so that the release will not trigger. If we're not expecting the change, doing that here will prevent that from occurring. However, in more mature organizations where people are doing the right things with Git merges and Git approvals, where your CSV repository is managing those releases and you've got the practices in play to do that, then you would always leave that trigger enabled, because you can be assured by virtue of the process and by the organization living up to that process that the artifacts will only push when they're authorized to push. But that's, bear in mind, those are not your only decision gates here. There's more to this. We're going to add a stage, and we're going to select an empty job. There's a lot of garbage out there on the internet with how to do this, and almost all of it is dated. This used to be called classic mode. Now it's called empty job. And now we're going to go here. We could name it here. We could change the name if we want to. I'm not going to do that. I'm going to click here on job. This is the agent. You used to be able to pick a number of agents here, but Microsoft has changed this. Now you can only pick a 2009 agent with VS 2019 or Azure pipelines. You'll pick a hosted Windows agent that's a microservice with VS 2019, which is the default. So if we go back here, if we were to delete this, and add it again and select empty job, and X out over that and go here, you see that agent is right back where we had it. We're going to click on the plus symbol here. You remember when we added Charles Zip's Terraform plugin? Well, there's one thing you're going to do first, which will be installed by default, and that's to actually install, you're going to install Terraform. You see by Charles Zip, his name comes right up. And you could pin the version if you want to. I pick latest. I always pick latest because I want to know the latest version of Terraform that Microsoft is providing. The last time I ran this, it was 1.25. And Microsoft is much more slower about upping the versions. And sometimes they'll skip several versions. So they might, right now, 1.4 is the latest. So we might find that they'll take this up to 1.35, for example. Now I'm going to click on the plus here, and I'm going to type Terraform again. And now I'm going to pick execute Terraform commands. I'm not doing the installer. I'm doing this. The default is to use Azure RM, which is the Azure Resource Manager, and we're going to pick AWS. And we're going to modify the display name to Terraform init for initialize. Now, this is really important. Don't forget this, or you'll get meaningless errors. You've actually got to browse to the directory in the build pipeline where the artifacts are. You click on the ipsilon, and you see, you remember that? We had picked that earlier. Down arrow. Manifest, down arrow. You remember the files were stored in main. Down arrow, here they are. That's as far as you need to go. You need to not forget that step. And now you can see all of that here. We have to provide additional information. What is the service connection? What is the bucket? What is the key file? Where do we get the key file? We get it from the code. See, that's the key file. And that's it. The next step, remember the previous slide, Terraform init, validate, plan, apply. Rather than type all that over again, I'm going to clone it. Now the default action on these is abort on failure, and I recommend you not change abort on failure. So now we go here and we change init to validate. We right click and we clone it again. And now we're going to change the display name to plan. And you see we have to repick the service connection. Clone it again. And finally, we're going to do apply. The last thing I'm going to do, but I only do this in non-production environments, I'm going to clone this again, and I'm going to call this, destroy. And again, I will never do this in production. And I will right-click here, and I will disable that. I have to go up here and name this. And we can go back here and we can review this. I want to do a few more things first. I'm going to go back to the pipeline. I'm going to click here. And I am going to add a pre-deployment approval gate. And you would put users in your DevOps team here. You can change this approval gate to where if there are multiple approvers, require only one, require at least two, require all. Now, you might be wondering, how do I see if this is going to run like this? Well, we have to rethink this job. We really didn't want to do this or this because we're not going to know if it's successful or not. So I'm going to drop this. And I'm going to drop this. See, I'm always setting you up. Now I want you to think about things, about why we do them the way we do. I'm going to go here and I'm going to click on add. I'm going to add another empty job. So stage 1 is here where the artifacts get copied. Stage 2, we're going to do all of this and stop at plan. And we have a pre-approver, which typically for AWS is you allow any one person to approve it. And usually that's either the person who deployed the code or someone else who is on that team. Now, we're going to do a post-deployment approver. And here is where you're going to want to say, put somebody else in here, and I don't have other people set up in this. Let's see, Fritz. Yeah, so you would put typically a peer or a team lead here. Somebody, you could put yourself in here, but the practice should be if you're pushing the release, if you wrote the code, you should not be the one who's approving the post on stage 2 to approve. you should not be approving the actual deployment. You'll note I did that post-approval here because here we're just going to enable a schedule. So if it gets approved Monday through Friday, no, I don't think so. Not for ERP. Usually for ERP, it's Friday, Saturday, or Sunday night and nothing else. And so this will trigger when this condition is met, meaning you can push it through during the business day. You can push your code out and it'll go through the approval process, and then the manager does the final approval, and then it just sits in the schedule and it doesn't run until the weekend. And that doesn't have to be at midnight. Let's say you want to do it like this. Let's say you want to get up on Saturday at a reasonable time. So let's say you're going to look at it at 8 in the morning on Saturday. You're going to log in and you're going to check that this deployed successfully. The manager approves it, then typically it goes back to the person or the team that wrote the code to make sure it actually deployed the way it was supposed to. And there we go. And now we'll go here, and guess what? We're going to do the same thing we did before. Terraform installer. Terraform, run commands. In this case, AWS. We're going to call this init. Remember, we're going to walk down, click on that ellipsian, and we're going to walk down to where the artifacts are, not the parent directory, but the directory where the actual Terraform files are. We're going to pick our service connection, and we're going to pick the S3 bucket. And remember, the key file comes from the code. Now we're going to clone it. Clone it again. Do the plan. And remember, we have to do this again. And do the apply. And then if we want to have, we can put destroy here. But typically what I do, if this is a scheduled task to destroy, we would have plan and we would add the option destroy here. And it would do a Terraform plan destroy and tell me what I'm going to be destroying. And then we would modify this to destroy here. And then that's how I get at nighttime based on a schedule. It's going to tear all that down. I'm not going to save this. I'm going to show. So we're going to look at last night's run on the release because it looks a little different. And you see stage 1 here. You see who approved it? And this is what it said it was going to do. 85 to add, 0 to change, 0 to destroy. And then we go to stage 2. Drop down to apply. $85 were added, 0 changed, 0 destroyed. And the post-deployment approval. There you go. Now, incidentally, you might be wondering, well, what the heck was release 11? Well, I'm very disciplined about our development cloud spend, and you should be too. If I'm spending more than $5 a day, that's bad. If I'm spending more than $5 a day, then, or if somebody on the team is spending more than $5 a day development for a client, then I need approval, because it shouldn't be costing more than $5 a day. Unless you're doing something special, like Andrew was doing a demo that we did at Microsoft headquarters not long ago for the completed multi-cloud pilot. And he was demoing that, and that cost like $50 a day, and it had to run for 3 days. So that he had to get approval on. So I go here, and this is what I ran. You see, I built that cluster, and I didn't wait for a scheduled release pipeline to delete that. I just deleted it. I didn't need it anymore. Boom, it's gone. And by building this way, if I'm smart about it, every time I do this, it's about 17 cents in cloud spend. Provided that I'm sitting here in the sandbox, and I know it takes 20 minutes, so I set my timer to remind me, or I set a calendar reminder, and then I go back in here and I check, and the deployment's good, then I immediately run a destroy. And I know I'm good. So we have covered a lot of ground today. And I know that this is not enough for you to become experts in doing this. Ultimately, my experience has shown that we have to take the little bit that we've learned and apply that learning by hacking at it and spending another 100 hours perhaps, maybe 200 hours in this case, because you got to learn the cloud provider stuff, you've got to learn Terraform, and then you've got to practice to get good. And I would tell you quite frankly, to elevate your skills, this is a 6-month elevation. We do need to conclude though. So I would entertain any closing questions before we start to break down. Yes, sir.
So what you made earlier throughout this, there are events or things, choices you can make early on that can cause real blame the next day that don't do those things. For example, you talked about setting up multiple tenancies. Right? Now, are you talking about putting all your test things in the test tenancy, or would the test tenancy just be things with the DBA, trial Terraform, to see how things would go before you shut it down and be able to
So the question for the recording is, one of the earlier things that I talked about that had to be planned out. These earlier things, this is where an enterprise architecture is so important. You talk about these things, then you document them, and that becomes a living document within your organization. As I've pointed out in previous sessions, what our competitors are calling enterprise architecture is not enterprise architecture. What they are producing is technical architecture. And that is, in my opinion, that is taking the cake out of the oven and it's half-baked, and that cake is going to sink. You now understand, you can now grasp why enterprise architecture is so important, because these decisions are made as part of the enterprise architecture. and then you revisit the enterprise architecture, and you flow down the business architecture. Usually you pass through the business architecture. It's usually reviewed once a year unless there's a significant organizational change. But then you flow down from the business architecture into the information assurance architecture, and you proof test that, meaning, is this change going to add or subtract risk to the organization? And is it regulatory compliant? And is it affordable? If you pass go on that, then you move to the technical architecture, and it's in the technical architecture in particular that your question is addressed. And if you make the wrong decisions, there are significant consequences. Case in point, let's say that I build a Kubernetes cluster, and it should have had a CNI interface in the beginning. A CNI interface is a private network interface. And I didn't do that in the beginning. Now I need to do that. Well, okay, let's just add the CNI interface, set private cluster equals true, and run it. It fails. It fails because the plugin provider module won't allow you to do that. And you only find this out by doing. So what does that mean? That means, wow, we thought we were going to get that out overnight. And now we've discovered we have to destroy and recreate our cluster. And we have to test this in the sandbox, and then in QA, and then we can deploy in production. Now it's going to take us 3 weeks to get there because it's a very significant change. And in doing so, then we discover that we haven't been managing our Git repositories correctly. And now that we've destroyed and recreated the Kubernetes cluster, we can't redeploy our pods because we didn't manage the namespaces correctly. Back to enterprise architecture, which are the 3 architectures. And in the enterprise architecture, we would define in the information assurance architecture what the process would be for managing things like namespace in a Kubernetes cluster. It's literally a line item that we have in our template that we talk about during the IA process. So, oh, that was missed. All right, so now I'm trying to do this in my test cluster, and I haven't implemented the process, the practices, the code, and the leadership to do that. My culture is broken. Therefore, my strategy is broken. Therefore, I am incurring a huge amount of technology debt with one little change, adding a CNI interface. I can't do it now. Look at all this technology debt, and this is just one part of the stack. This is why I've presented what I've presented this week. It matters. More questions?
What is, do we need to run Terraform to destroy the thing or anything? Or how should we tear it down?
Yeah, run a Terraform destroy, and it will Terraform apply -- destroy -- auto - approve, and that'll destroy it.
Destroy and then -- what?
Auto - approve. Or you can just terminate the subscription and that'll destroy everything.
And that's just within the billing and the AWS?
Yeah, you've got a credit, and then that when you exceed that dollar amount on the free tier, it starts charging your credit card. And that's on a per month basis. In Azure, you get a one-time, $250 now, I think, credit, a $200 credit. And once you've consumed it, it's gone.
And then do we need to do anything for the Azure AD?
You probably haven't done enough with, we haven't done enough with Azure for you actually to incur any charges. That's good for 30 days, and it's associated with your email address. So what I used to do was I used to just create a new email alias in Gmail, and you can just get an endless supply of free trial subscriptions that way. But, you know, with us at David Camp, we've gotten too busy to do that now. Now we need that history, because now we're doing this. This is how we work now. This is how we build it. Okay, so thank you, everyone. I'm going to go ahead and end the recording.